Alrighty, I'm doing something different and I've had several false starts, so let's see if it works. I am doing a screen recording instead of doing a PowerPoint recording, and what I'm hoping is that I can capture the PowerPoint and also be able to navigate out of the PowerPoint to do Desmos at the same time. So if I run a regular slideshow, we're going to see what happens. So hopefully we're recording the slideshow. This lesson is about using Desmos to highlight, to determine domain and range and what it is for a function to be increasing or decreasing. And this typically is a challenging skill for students. And my goal with this is to do something differently this year. It's to use Desmos to give you a visual of it. So we're going to start with range, which might seem weird because we always talk about domain and range, domain and range, domain and range, and domain always comes first. But domain is like kind of the weird one here, as opposed to range. Range is going to do more what I want it to do. So let's recall what range is. Range is all of the possible y coordinates in a function in those xy pairs. So when you are, and I don't have all my regular PowerPoint tools, so I guess my mouse, hopefully you can see my mouse. But when you're looking at the XY pairs in the function and you look at what numbers you are allowed to have for your Y coordinate, the range is all of the possible numbers that you might have for the Y coordinate. Now we also talk about it as the outputs of the function. So you put in an X value and you get out a Y value. What might you get? Now, one of the things I noticed looking at our first set of tests is that as a class, we seem to be more comfortable working with the y than we do with the f of x. So I'm going to do this in multiple ways here. We're going to look at the y's, and then I'm going to try to transition into the f of x's and kind of work on the comfort level there. So as an illustration, in the function y equals x squared plus 4, can y ever equal -1? So I'm going to wait. You can pause the video if you want to, but I'm going to wait for a couple of seconds here and give you a chance to think about that. Can y ever be equal to -1? Okay, that wasn't super long. Hopefully it was long enough for you to kind of come up with something. Again, you want to pause it. But the answer to that is no. And the reason for that is if you take a number for x, any number for x, and you square it, you're going to end up with a number greater than or equal to 0. Okay, so if you take a 0 and you square it, you would have 0. And then any positive number when you square it would be positive. Any negative number when you square it would be positive. And then you're going to add 4 to it. So there's no way that you could have a positive number, add 4, and have it be equal to -1. Or if you have a 0 and then you add 4, that it could be equal to -1. So therefore, -1 is not in the range. Okay, so it's not in the range of that particular equation. So remember, the range is all the possible y coordinates, and we know that y can't be -1. Therefore, -1 is not in the range because it's not a possible y coordinate. Now, but what numbers are in the range? What numbers could y equal? If the range is all the possible y coordinates, and we know -1 is not one of them, well, what could be in that? And so we're going to take a look on Desmos. And so hopefully I can escape out and I can click on over to Desmos and we can type that in. Okay. And there's, whoops, don't do that. There we go. Okay. And there's the function. Now I want you to take a look at the y coordinates. I'm going to hover over this. And notice that the y coordinate is 13.7 something. It's like an ugly decimal. Now the y coordinate is 11.0225, 7 point, okay, and so forth. And when I come down here to the minimum, the vertex, the y coordinate is 4. And now the y coordinate is going back up again from 4. So we have 4.32, 5.2769, 8. Okay, and it's going up. So the y coordinate, the smallest the y coordinate can be is 4. Now, in the past, what I've just done is said, okay, so y must be greater than or equal to 4. But I don't know that, I think I ended up with a lot of students that were writing it down and they couldn't really see y. So over here, I'm going to type in y is, now to do greater than or equal to, the greater than symbol is in the lower right side of your keyboard. It's next to the question mark. And then you could just type the equal sign and it'll put it underneath there. Okay, y is greater than or equal to something. Or you can get that by clicking down here and you can see that there is a greater than or equal to symbol there. And I'm going to type in y is greater than or equal to 4. And what I want you to notice is that you can see the shading going up and the entire parabola is in the shaded region. And that actually would let you know that that is the range. The range is y is greater than or equal to 4. So no, it can't be a -1. -1 would be down here. Okay, if you look at your y-axis, -1 is right here. So no. Also, it can't be equal to 1. Or 2, or 3, or anything going up to the 4. So not 3.5 or 3.9 or 3.99999. It starts at the 4 and it goes upward. Now, just for contrast, I want you to see what it looks like if you get the wrong number. So let's say you said y is greater than or equal to 2. The reason you know that's not correct is because you have extra stuff in your range that is beyond what the parabola is. Like the parabola doesn't actually go down to the 2. And so you got this extra piece. All right. It's all the possible y coordinates. But the way I've got that, 2 would be a possible value. And it's not because the parabola doesn't go down that far. Or if you set it up too high, all right, that doesn't work because now you've got possible y coordinates that are actually not in your shaded region. And so you'll know if you state the range correctly, if you can get the entire function into that shaded area with nothing left over. Okay, you don't want anything hanging out over. So the range for this function is y is greater than or equal to 4. So if I come back to the PowerPoint, we want to be on this one. Okay, and let's go ahead and do this. This is like very unconventional for me. And now I can find my tools. So there they are. Normally you can't see when I do that, but you can now. So we had, okay. What numbers are in the range? Y is greater than or equal to 4. And the way you would say that is you'd say like R for range, and then Y is greater than or equal to 4. And I know that that's correct because I can see it on the graph. Okay, where's my mouse? There it is. All right. All right, now what about the domain? So we're going to go back to x squared plus 4, and I obviously don't have the animations on here. So I want you to think, is there anything you can't use for the x? So like think about that for a moment. Is there anything you can't plug in? No. Okay, so you could plug in positive numbers, you could plug in negative numbers, okay, you can plug in decimals and fractions, square roots, or like you can plug in 0. There's nothing you can't use. Therefore, the domain is all numbers because we haven't excluded anything at all. And I'm going to put the word real in there because we have the possibility that they're not real, but you don't know what those are yet. So basically all real numbers. So can we see that on Desmos? That's a little tricky. Okay. So let's go back to this. So with the range, or sorry, the domain, let's say I pick something. Okay, I say x is, because domain is all your x's, x is less than 1. Okay, and I want you to notice that, oh, we should probably do x is less than or equal to 1. Okay, you can know that that's not correct because you've got all this like parabola that's not in the range, or not in that domain. And so you might say, well, what about if I do x is less than 100? Well, now it looks like I've covered everything, but what if I zoom out? Okay, and I keep zooming out and I keep zooming out, and this is like really hard to see. Like I'm gonna have to go ridiculously high. I probably should not have picked a number that high, but because now I'm up to like 10,000. Here we go. I think we're about to get there. I'll have to do this a little differently. There we go. Okay, I have to come all the way up to 12,800, but finally I can see that I have a piece of the parabola that's like stuck out, like out of here. Okay. It's not in my shaded region. So I might say, well, what about if I change that to 101? Oh, no, that didn't cover it. Maybe 110. Oh, well, now I've got it covered again. All right. But if I come up just a little bit higher, I have to come up to 14,000, but now my parabola has snuck outside again. And the idea I want you to get from that is that no matter how big of a number you pick, you can zoom and go far enough out on the plane to where the parabola finally creeps outside. And it might be slow going. Okay, that looks like a vertical line, but it's not vertical. So I might say, okay, well, what about, 120? Like, oh, okay, now I've got it. Well, nope. If I come up here, and we could keep playing that game. Okay, so we're up to like 17,200. But we could keep playing that game, right? And keep making that number bigger and bigger and bigger, and we would eventually like creep out of it because the parabola keeps going side to side. Now, I could also play this game on the other side of the parabola. So if I wanted to change it to, well, let's just go in the other direction, right? And we'll make it, it is less than or equal to, oh, wait, that's what I had before. We want greater than or equal to, okay, negative 120. We could keep playing that game, okay, and we could keep going in the other direction. Oh, well, like what if I make it negative 130, right? And now I've got it in there, and oh, wait a minute. Oh, now I've creeped outside again. I'm up to 19,000. I say, oh, well, let's change it again, okay? And I know this is like kind of a weird thing. Oh, I captured it again, but I can just keep going, and we could creep out on the other side. And so the idea there is that it doesn't matter. You can make these numbers bigger and bigger and bigger and bigger. Okay. And would we have to go super, super, super high up on the y-axis to get out? Yes, but we would get out. Therefore, the domain is all numbers. Okay. It's everything. Eventually, I would need to shade the entire plane, would have to be shaded in purple. All of it would have to be shaded, because that parabola, if I cut it off at any point on either side, eventually the parabola would peak out. Now, this is like, obviously I've messed up my window here. So I'm going to click that house button, and that's going to take me back to my normal window there. Okay, so for domain and range, the range you can get by like y is, because range is all your y's, okay? And so you can go like greater than, less than, play around with that. And your domain is pretty much all real numbers, and that's going to be the case for all parabolas forever, okay? All right, so now I want you to take a try and do a few on your own. So we're about 13 minutes in. Pause the video, hop on over to Desmos, and do a few of these on your own. Okay, so at this point, I'm going to click out of here. So if you want to like take a screenshot of this, you want to clip it on your phone, I'm going to change my screen over. We're going to go back over to Desmos. Okay, now for the domain for all of them, the domain for all of them is all real numbers. So we're always going to get that one right. Let's take a look at this first one. So we have f of x is equal to 3x squared minus 6x minus 3. And what we want to do is locate where that vertex is. I'm going to slide that up a little bit. Okay. And I can see the y coordinate on the vertex is -6. And so I'm going to try y is less than or equal to -6. Oh no, I shaded in the wrong direction. Okay, so less than shades in the wrong direction. That is shading down. So I'm going to come over here and we'll just edit that and we'll make it greater than or equal to. That looks good. Okay, so I've captured all of the parabola, but I don't have any extra space that where I'm saying something is in there that's not in there. So for that one, your range is y is greater than or equal to -6. All right, next one. F of x is equal to -x squared minus 4x plus 3. And obviously I'm in the wrong spot. So here we go. And my y coordinate, remember y range is your y's. And so I'm probably going to be playing around with that 7 there. Let's try y is greater than or equal to 7. Ooh, no, I went in the wrong direction. Okay, so this one, because we're going y is greater than, so you can tell we're going numbers greater than 7. We have like 8 and 9 and 10, okay? But we actually wanted numbers that were less than 7. We want the 6 and the 4 and the 2 included. So if I go over here and, whoops, there we go. And shade y is less than or equal to 7. Now I am capturing the actual values in the parabola. And again, if I trace the parabola, you can see my y values, like it's 4.2444. They're all less than 7. So those are the ones I wanted. All right, next one is -1/2, x squared plus 3x plus 4. And at this point, you might be feeling like pretty good about it. Oh no, a decimal. What? Could it be a decimal? Why, yes, it could. And so we'll try it. Y is less than or equal to 8.5. And there we go. And so that captures everything that I needed without anything extra. So y is less than or equal to 8.5. And our last one is 2x squared plus 3x minus 5. And I'm going to have to come down here to see it. And again, it's range. So we're looking for that y coordinate. Did I do that right? 2x squared plus 3x minus 5. That's what I copied down. I could have copied it wrong, but we have like a yucky number there. That means I did something because I tried to write all of these so they would come out nice. But never mind. So what is this? This is going to be y is greater than or equal to, and what was that number again? -6.125. So -6.125. And that works. And I'm working off a Post-it because I knew I was going to have to click off of the PowerPoint. So if I copied it wrong, and it was actually like a -3x or something like that, you get the idea. Okay, so you would find what that number is. And essentially what you've done at this point is you have learned how to write domain and range using inequality notation. So let's go back to the PowerPoint. 2x squared plus 3x minus 5. No, I copied it right. Now, how would you end up writing those answers? What you should probably do to write those answers is you would have like domain. And I'm a fan of that. Okay, it's a symbol for all real numbers. It's like the R and it's got like the extra line on it. So you can do like the letter R and then put the extra line on the back. And then your range, you would have R for range. And then you would have something like the one we just did. Y is greater than or equal to -6.125. And that is pretty much how you would do domain and range using what's called inequality notation. We're going to look at a different notation for that next class. All right. Now, what about increasing and decreasing? So we're going to do increasing and decreasing as well in this video, and it's probably going to run a little bit long. I'm sorry. I've never done this before with this. So with increasing and decreasing, let's consider that particular function there. And we've talked in class about what it means for something to be increasing or decreasing. So I'm going to go ahead and grab the yellow highlighter, And I know that increasing means it's going up from left to right. And I'll go ahead and do decreasing in the green. Okay. And so what I want to do, so this is my decreasing over here, and this is my increasing over here. What I want to do is I want to be able to write this in inequality notation. And what we're going to do is do this by graphing it and highlighting it in Desmos. And this time, because of what we're doing, we're going to be focusing on the x coordinate, which is a 1. That is because in functions, x coordinates do not duplicate and y coordinates do. So I don't want to use the 3 there, because the 3 is going to end up highlighting both sections. All right. So we're going to do this using the x coordinate. So let's take a look and see how that goes. Yep, discard. And let's come over, and we are looking at y, or you can use f of x, would work. So y equals x squared minus 2x plus 4. Okay. And again, that point right there, we're noticing the x coordinate of that point. So if I want to get where it is decreasing, it's decreasing to the left of that point. So I want to head like in the left direction. That's my less than direction. So I'm going to say x is less than 1, and that is my decreasing. Okay. That is my decreasing interval. If you trace the parabola inside the green, okay, it is clearly going down. That is my decreasing interval. To get my increasing interval, well, that's going to be x is greater than 1. And if we come over here and trace it, why, yes, I am heading up from left to right. So this, I've never taught it this way before, and I apologize that the video is like long. I hope it works. So what you could actually write over here is, this is my decreasing in the green, this is my increasing in the purple. And as you're tracing it, green, 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 decreasing, 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 decreasing. And right here, it is purple, 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 and it's increasing, 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 increasing. Therefore, I know that x is less than 1 is my decreasing interval, and x is greater than 1 is my increasing interval. All right, hopping back to our PowerPoint. So I think we did that. Okay, so we're going to use the inequalities, which I did. And the way that you would write that is you would say something like the increasing was x is greater than 1, and the decreasing was x is less than 1. And you would not use the or equal to, because technically at the 1, that's the lowest point. It's not really doing either of them. Although I have seen the endpoint included in certain curricula, but we're not going to include it. Okay. And if you did that, you would get full credit, okay, for inequality notation. So as before, I'm going to have you pause the video, and I want you to try a couple of these on your own, and just highlight those intervals and see how we go. All right, let's take a look. So I've got a, there we go, discard, and let's come over to Desmos. And our first problem was, what was it? Negative x squared minus 2x plus 4. And we're going to like home in on that x coordinate. So it's the -1. And I'm going to go with x is less than -1. Ooh, it'd be good if I put the negative in. There we go. X is less than -1, and that is my increasing interval. So my increasing interval is x is less than -1, which means my decreasing interval is probably x is greater than -1. And so we can see that in the blue. So if we look at this, we've got increasing, increasing, increasing. If you look at that y coordinate, take a look at that y coordinate. The y coordinate is increasing. Okay, because it's going up. Y coordinate is going up. Right here, we hit the maximum at the 5 there, and then decreasing. Now you can see it's 4.6. Now it's 3.6. It is heading down, decreasing. And we're looking for the X values where that's happening. Second one is, who knows, it's getting dark in here. 2x squared minus 12x plus 14. All right. So there it is. Okay, and we're going to focus on that x coordinate because the -4 isn't super helpful. So with x is less than 3, that appears to be my decreasing, and x is greater than 3 is where it's increasing. So decreasing, 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 and then increasing, increasing, increasing. Now, if you wanted to change the color of the highlighting, so if you were asked to highlight it in a specific color, what you would do is click in that box and then click up on that gear here, and you'll see that pops up and you can actually change it. So if you wanted, if like you have directions that say highlight the increasing interval in blue or decreasing interval in blue, and then you'd have to click on the next line down and the increasing one in green. Okay, and you can actually change the colors of the highlighting there. So if you are asked like specifically to highlight in a specific color, then there you go. Okay, and what am I looking at? That was x is less than 3 and x is greater than 3 for whoops. X is less than 3 is decreasing and x is greater than 3 is increasing. So how would you write that for your answer? So if you were asked to actually write it out, you would say on this one, x is less than -1, and this x is greater than -1. For this one, x was greater than 3 and x was less than 3. And that is your full credit for your inequality notation for writing increasing and decreasing. And as I said before, really, really try not to memorize something like if it's pointing this way, it's doing this, because it won't work. I'm going to give you a problem in your homework where that's not going to work for you. Okay. So speaking of your homework, here we go. So practice work, finish for homework. For numbers 1 through 5, state the domain and range. Remember that the domain is all real numbers for all of those problems, okay? If you don't get that right, you weren't listening. It's all real numbers. The range, you're going to have to play around with the y is greater than or y is less than, but use Desmos to check what you want to do with the shading. For numbers 6 through 10, state where the function is increasing or decreasing. And if you take a look at number 10, that is actually not a parabola. That is not a quadratic. So in order to emphasize, like, don't use like patterns, okay? But see what you can do with that. I do expect people to ask questions, but I also expect you to have an answer to give for it, even if you're reasonably sure your answer is wrong. So I know this video ran a little bit long, not too bad. It's still less than half an hour, but longer than usual. And thank you for putting up with me clicking in and out. Hopefully it works and we have a video that's actually going to help you guys. If it's not, let me know. All right.